Imagine a future where our energy sources are clean, sustainable, and virtually limitless. Is this a distant fantasy, or is it closer than we might think? Green hydrogen might hold the answer. Our planet is in dire need of renewable energy sources. Traditional fuels like oil and coal are not only finite but also emit harmful greenhouse gases when burned. The increasing global demand for energy, coupled with the urgent need to reduce carbon emissions, has driven us to explore and innovate. Enter green hydrogen, a potential solution to these pressing issues. Green hydrogen, in essence, is hydrogen produced through an environmentally friendly process. It's not a new concept. In fact, hydrogen has been around since the dawn of time. It's the most abundant element in the universe and the third most abundant on our planet. However, it's the means of production that sets green hydrogen apart from its less eco-friendly counterparts. Now you might ask, what makes it green? Well, the process of producing green hydrogen involves renewable energy sources such as wind or solar power. This method, known as electrolysis, uses electricity to split water into hydrogen and oxygen. The key here is that the electricity comes from renewable sources. This means the entire process is free of harmful emissions, making green hydrogen a truly clean source of energy. But it's not just about being clean. Green hydrogen has the potential to be a game changer in the field of energy storage. Unlike electricity, which needs to be used as soon as it's generated, hydrogen can be stored and transported, providing a solution for one of the biggest challenges in the renewable energy sector. So, green hydrogen offers us a vision of a sustainable future, where our energy needs are met without harming our planet. It's a beacon of hope in our fight against climate change, offering a way to harness the power of renewable energy in a new, efficient, and clean way. So, the question is, how do we unlock this potential source of energy? Let's dive into the fascinating process of green hydrogen production. Before we dive into the production process, it's important to understand what green hydrogen is. So, let's take a moment to define it. Simply put, green hydrogen is a type of hydrogen fuel that's produced using renewable energy sources, such as wind or solar power. This makes it a clean and sustainable form of energy, unlike its counterparts, gray and blue hydrogen. Gray hydrogen is the most common type and is typically generated from natural gas through a process called steam methane reforming. This process unfortunately results in significant carbon emissions. Blue hydrogen, on the other hand, is the same as gray, but with an added step to capture and store the carbon emissions, making it a bit cleaner but not completely carbon-free. Green hydrogen stands out as the truly eco-friendly option, as its production process emits no greenhouse gases and relies solely on renewable energy. Now that we have a basic understanding of green hydrogen, we can explore how it's produced. The process of producing green hydrogen isn't as complex as you might think. It all starts with water, H2O. Imagine a simple molecule of water, two hydrogen atoms bonded with one oxygen atom. This humble molecule is the starting point of our green hydrogen production journey. Now, let's introduce a process called electrolysis. It might sound like a word straight out of a science fiction novel, but it's a fairly straightforward process. In the simplest of terms, electrolysis is the process of using electricity to break a molecule into its constituent parts. Think of it as a magic trick. We apply an electric current to our water molecule, and voila, it splits into hydrogen and oxygen. But this isn't just any electricity we're talking about. To keep the process truly green, we're using electricity sourced from renewable energy. This could be power generated from wind turbines, solar panels, or even hydroelectric dams. So we've got our water, we've got our renewable electricity, and we've set the stage for electrolysis. What happens next? We introduce our water to an electrolyzer, a device that facilitates this reaction. The water goes in, and with a zap of renewable electricity, the water molecule splits. Hydrogen bubbles up one side, oxygen the other. But it's not just a case of splitting water and collecting hydrogen. The hydrogen we gather from this process is a gas, and gases are notoriously difficult to store and transport. So, we often compress the hydrogen into a more manageable form, such as a liquid or a solid. And just like that, we have green hydrogen. But what does this mean in terms of energy? Well, that's a story for another scene, but rest assured, the potential of this little hydrogen molecule born from water and renewable energy is nothing short of astonishing. You might be wondering, we've got green hydrogen, now what? Well, this is where the magic happens. In the world of energy, green hydrogen is like the new kid on the block. It's got the potential to revolutionize how we create and use energy. But how does it do that? The answer lies in something called fuel cells. A fuel cell is a device that converts the chemical energy from a fuel into electricity. In the case of green hydrogen, the fuel cell combines hydrogen and oxygen, producing water as a byproduct. This process generates an electric current, and voila, we've got electricity. Green hydrogen's role in energy production is essentially as a clean, zero-emission source of power. But that's not all. Green hydrogen's versatility means it can be used in a whole host of different sectors. Take transportation, for instance. Vehicles powered by hydrogen fuel cells don't emit harmful pollutants, only water vapor. They can also travel similar distances and refuel just as quickly as gasoline vehicles. This makes green hydrogen a promising alternative for reducing emissions in the transport sector, from cars and buses to trucks and even ships. Now let's consider heating, a major source of carbon emissions. Green hydrogen can be used in hydrogen boilers and fuel cells to generate heat without releasing carbon dioxide. This could be a game changer for our homes and industries, helping us transition to a more sustainable heating system. And it doesn't stop there. Green hydrogen could be used to store excess renewable energy like solar or wind, and convert it back into electricity when needed. This could solve the issue of intermittent supply, often a challenge with renewable energy sources. The potential applications for green hydrogen are indeed vast. It's like a Swiss Army knife in the world of energy. Coupled with its environmental benefits, green hydrogen could play a pivotal role in our transition towards a cleaner, more sustainable future. The possibilities are vast, but let's wrap up with some key points about green hydrogen production. Green hydrogen production might seem like a lot to wrap your head around, but there are some key points to remember. Firstly, green hydrogen is an exemplar of clean energy. Unlike its gray and blue counterparts, which are produced from natural gas and leave a carbon footprint, green hydrogen's only byproduct is water vapor. This means it's not just carbon neutral, but actively helps in combating climate change by replacing fossil fuels in various sectors. Secondly, the production of green hydrogen is inherently sustainable. The process involves electrolysis, where water is split into its component parts, hydrogen and oxygen. The electricity used in this process comes from renewable sources like wind, solar, or hydroelectric power. This way, we're not just avoiding harmful emissions, but also leveraging the abundant and renewable resources Mother Nature provides us. Thirdly, the applications of green hydrogen are wide-ranging and impactful. It's not just about powering our homes and vehicles. Green hydrogen can be used in heavy industries like steel or chemical production, which traditionally rely on fossil fuels. It can also be used to store excess renewable energy, solving one of the key challenges of the renewable sector. And let's not forget its potential in the transportation sector, particularly for heavy-duty vehicles, ships, and even airplanes, which are difficult to electrify. But it's not all sunshine and rainbows. There are challenges to overcome, such as improving the efficiency of electrolysis, reducing production costs, and developing infrastructure for storage and transportation. But with continuous advancements in technology and increasing investments in green energy, these hurdles are being steadily addressed. So as we look to the future of energy, green hydrogen emerges as a promising contender. It's a topic worth keeping an eye on as we continue our quest for clean, sustainable energy sources.